129S, and we're down here. There. So this is the last chapter from the book, Cross-Site Scripting, which you've probably been doing already in the Web Security Academy. And then last class, I'll talk about hacking APIs with Postman and a couple of CTFs I've got set up for that. And then just the final exam. So we're pretty near the end of this course. So let's talk about this stuff on chapter 12, which is here. All right. All right, so cross-site scripting. Let me get this sized correctly for the remote viewers. I guess that's about it. All right. So the point of this is you are attacking other users in cross-site scripting. You're putting script on a page that the developer did not intend to put there, and this runs in the browser of people viewing the page, so it can do unauthorized things, like in principle keylogging, stealing cookies, sending data to a third party, and so on. And it's, of course, the most common web application vulnerability in the world, which we've mentioned before. So here's the three basic categories: reflected, stored, and DOM-based. DOM stands for Document Object Model. So reflected is the most common, where you have a page that takes input from the user, and the next page repeats that user back, that information back. The most common one, for example, is a search engine. So if you just go to, say, Google, and you search for frogs, then the next page used to say results for frogs. This one doesn't anymore. I wonder what other search engine exists anymore. Alta Vista, Yahoo. Does Yahoo have a search engine anymore? It does. All right, let's search for frogs. And they're just copying Google. I wonder if any other search engines exist anymore. There used to be a lot of them. Does AOL have a search engine? I can't even remember what there was. There used to be something called Alta Vista. Oh, there's something called Ask Jeeves. Ask.com was another search engine. Still exists. Let's try frogs. I just wanted to show you the old way this was done, if anybody is still doing it that way. And everybody is not doing it anymore. Okay, it used to be that everybody would say results for frogs. They would repeat the word here. So you type in a search engine, and the results would be there. You know who might still do that is City College. Let's just take a look at that. There's a search engine on this page, which used to be really amateurish. So if I search for frogs, it used to be implemented by a guy on our staff. Now I think we're actually using Google. Yep. So this is still doing, all right, anyway, the point is they used to just put right up here, results for frogs, and that was a common place you'd find this flaw. Oh, somebody says DuckDuckGo or Yandex might have it. Anyway, I'm going to quit looking for an example because it seems to have gone out of fashion to do it this way. But the point is, you take data from the user and you reflect it back on the next page, and if you don't filter it, then you'll have cross-site scripting. So I made my own vulnerable demo site. So let me open this, and let's use this. All right, so I need to go to, I'm just opening it in Burp, although I'm not sure we're going to need Burp for it, but it's just where I like to do all my demos. So it's http ad.samsclass.info. All right, and so now I want to go to XSS. I'll stop this nonsense. Yes, it's supposed to be HTTP, which it understood the first time, and it kept changing it. http://. All right, there we go. All right, so here's a reflected XSS. So you can have a message like developer is drunk, and when you submit, it puts that on the next page. And so you could put in a script. And since it doesn't filter, then there's a pop-up on the next page. So that's the simplest kind of reflected XSS. And we'll need this for some other demonstrations. So that's reflected cross-site scripting. You send a request with some data, and it comes back to you and runs. So now at first, this seems like you haven't accomplished anything because you just run something in your own browser. So you haven't hurt anybody, but what you do is you craft this URL that contains the script, and then you send it to somebody else. The attacker crafts this script and then sends it to a target. Now the target sends the malicious request, and now it runs there. So they're running script that came from the attacker and then went to the server and then came back from the server. So the script made this path. The script was sent up to the server. The script was sent here, and then up here and down here. And so it runs in this browser. That's the classic requested cross-site scripting. And so here's details of the attack that we've done in the project. So the user logs in and has a cookie to identify themselves. So the attacker somehow tricks them into running a malicious URL like this that will have a page and it will have script in the URL. So when you trick the attacker into doing that by doing something like sending them an instant message or embedding it on a page, somebody reading it, somehow you trick them into executing that URL, and it will now send, if you go to mdattacker.net, it will send their cookie. So now it sends their cookie to a server under the attacker's control, and they can find the cookie in the web server logs, and then they can copy that cookie and become you. That's what we've done. We've done that in the project and talked about that quite a bit. That's the classic attack. So the point is, you have to have a persistent cookie. Now, by the way, the cookie has to have no anti-CSRF protection. If the cookie tied to your IP address or something, then the attacker wouldn't be able to use it. But now if you have a persistent cookie, the user doesn't even need to be currently logged in. Their browser will always remember they're logged in and pass the cookie on up anyway. So it's this is the case with almost every website now. Almost every website lets you stay logged in forever without having to relog in. So you have a persistent cookie, and every request to that domain will always send the cookie. So now the same origin policy means this will only work if there's a cross-site scripting vulnerability on the website. There has to be some way to send a request to the right website that then sends data to the wrong website. That's the cross-site scripting vulnerability. So if I own evil.com, I can't get your target.com cookies. I can only get them if I trick you into sending a request to target.com. Then your browser will attach the cookie, and I have to somehow have script that will then send it to me. This is cross-site scripting, where you should be running script from target.com, but your script sends data to another site. So stored cross-site scripting vulnerabilities are just another way to do it, where you do not put it in the URL and bounce it off the server. You save it in some persistent post on the server, like at Facebook, for example. And so I've got that one here too. So the stored XSS demo is here. So if I put in a name of Fred and enter, then it says, hello, Fred. So, but I could put in a name like this. And now it doesn't work for some reason. That's disturbing. I may have to put it in. I'll put it in the comment at the other end. That's weird. There's no security on this. Let's go here. Oh, the page just quit working for some reason. Wow. Maybe something's wrong with my internet connection. Let me see. The streaming is still green. Well. All right. That's very bizarre. Shift refresh. Can we try a different browser? I don't know what's going on here. Let's try Opera. Browsers do implement increasing amounts of anti-cross-site scripting protection these days. All right, so there's the page. If I put in AA, it works. All right, let's inject over here. The other injection, for some reason, froze up on me. So if I go here, and I put an injection here in the comment, instead of in the name, although I think the name would also be vulnerable. Now I can post the comment, and there it pops up this box. So the comment includes it. All right, and I got to clear the old comments, and let's put in that script again. All right, now I think we'll have something that makes a little more sense. All right, now when I post that comment, there I get this pop-up. Okay, and the comments include only that. And you can do other ones, like for example, this is one that will add a malicious iframe to a page. You can add and erase the old comments and put this in. All right, and now when I post that, you'll now get this page that has another page inside there. Now it's blocked, which probably means City College has something like a content security policy now, which is a good recommendation, so you will not load in an iframe for just this reason. But sites that don't have a content security policy could be injected in another page, and this is one way to sneak malware onto a page with cross-site scripting. And here's another one. This is one that just redirects you to another place when you don't want to. So I erase the comments. Now I put in this comment. This is document object model, moving the whole location to City College. So I'll post that comment, and now you redirect to here. So this is one that's been happening a lot. All right. Anyway, there's a few examples of the stuff you can do with stored cross-site scripting. And so for stored cross-site scripting, instead of sending malicious URL to the user and tricking them into clicking on it, I just send data, including script, to a vulnerable service on the server that stores it, and therefore the poor user has no chance of getting a clue. You just do something like view somebody's Facebook page and it's got malicious script on it, and your browser has no way of knowing that the authorized developer didn't put that script on there. It's on the page. So, all right. And the third type is DOM-based cross-site scripting, where you run a script that did not come from the server at all, which is kind of amazing. And the way this works is you go to I send you a malicious link, and you click on it. The malicious link contains information. You send a request to the server, and the response comes back with no script, but the script in the request is used anyway. So I'll show you the example. The point of this is the script does not come from the server. It doesn't come from the server's response. All right. So the point is you can make a page that uses JavaScript to load something. So I think I've got an example of this. Is probably the easiest way to see it. Yep, DOM-based XSS. Let's go there, and let's see if I can see if this. All right, so here's DOM-based XSS. See, up here in the URL, I have a message, hi. And when you go to this page, the message there says hi. Now, this did not come from the server. That is not on the server. That is coming from the URL here. So if I change that to CCSF, hi CCSF, enter, there it changes there. But that did not come from the server. You can see the script here. It used script to read part of the URL and put that in the message. So that's this is being done locally in your browser. This part of the URL is being displayed here, and I can put a script up there. So if I put script alert 1/script up there, now you get a pop-up, but this did not come from the server at all. It was there in the URL, and your own browser put it there and ran it. So that's document object-based model cross-site scripting. And in order to be vulnerable for this, you have to do this where you take some other source of data and use it to calculate a number on the page, which is not that rare these days as pages get more complicated. All right, so let's try a Kahoot about this stuff. Let me see if I can find the right browser. This looks like the right browser. Oops. All right. I find I need a lot of browsers to get through the day. All right, there we are, 12A. Give it a few more seconds. Guess this is it. So what's the most prevalent vulnerability? Cross-site scripting, of course. All right, so script in the query string runs on the results page. What's this in a search engine? This is what I attempted to demonstrate. This is reflected cross-site scripting. It could in principle be DOM-based, but the most common case is reflected. You send up the data and the data bounces back from the server. All right, what attack can steal session cookies? Any of them, of course, any form of cross-site scripting. If I can run a script on your machine, I may be able to steal the cookie if the cookie was not set with the HTTP only flag. All right, and which attack steals all the data in a database? None of them, that's SQL injection. Cross-site scripting does not steal data from the server. That's why companies do not regard it as a high priority to fix it. It does not directly compromise the company's data. It does harm the users, but it's not considered as serious as SQL injection. At least it didn't used to be. And now I see some scanners flagging it higher. Alexander. Alexander K. Okay, good. All right. Good, I've got those winners. Now let's go back to the slides. All right. So, in real world, here's some examples of attacks. In 2010, Apache got owned. The popular source because they had a cross-site scripting in their issue tracking application, and the issue tracking is of course read by administrators. Like GitHub has, you can submit an issue saying something is wrong, and then the administrators read that to decide whether to update the code. So they injected code and obscured it, and now an administrator clicked the link, and therefore it's still the administrator's cookie. So now they had administrator rights on the server, and so they put a login form there to steal passwords from other people. So they got multiple administrator accounts in the Apache ecosystem. And so they got username and passwords, and then they fully compromised them. So that's how cross-site scripting can be pretty serious. MySpace was the first major worm. Sammy Kamkar became famous for this. He managed to evade filters and put up a post on MySpace that made every single person that see it add him as a friend and add that script to their profile, so anybody that saw their page would also add him as a friend, so he became the most popular person on MySpace within a few hours. This made him notorious and got him in some legal trouble, but it was an interesting demonstration of stored cross-site scripting. All right, and here's one that was pretty hilarious at the time. I remember this one. 2009, I guess, this guy called Strong Webmail invented one of the first email services with two-factor authentication. And he was so proud, he advertised that he would pay you $10,000 if anybody could hack into his email. And the problem is, it had a second factor that was like a telephone, SMS or something. But so somebody made a test account, one of the pen testers, and found out that you don't have to always get the SMS. You can check a box saying, trust this computer for 30 days. Then it stores a cookie on that machine, and you don't need the telephone. So he figured the CEO had probably done that. So he sent the CEO an email saying, I have won. The enclosed PDF proves I've won. When he opened the PDF, it ran a script, and the script stole his cookie. So then he used the cookie to get in, because you only needed the cookie if you were from that machine. So you can see a lot of flaws here. You could have fixed this a lot of ways. One would be to tie the persistent cookie to that machine so it couldn't be used on another machine. by including something unique to that machine, like an IP address. But anyway, they did win $10,000. Never, never claim that people can't get in. There was another guy around this time that ran one of these services to lock down your accounts. They have these things after you get a breach, and they've got your account number and your social security number. They have credit monitoring. So this guy ran a credit monitoring service, and he said, "This is so secure, I'm publishing my social security number everywhere." He put it in advertising and on TV, and he thought his service would save him, and it totally didn't. He immediately got hacked, and a bunch of credits was made in his name and got him in trouble. You have to be careful how much to trust your security solutions. This is pretty common, that people have big stunts where they offer some kind of reward, and then they're just humiliated. So Twitter had cross-site scripting worms in 2009. I remember these. These were pretty amazing. You'd get messages proliferating all over Twitter, repeating. Another stored cross-site scripting. And you can also do a virtual defacement, like I showed you when I had an iframe with CCSF in there. You can add other content to a page that the developer didn't put there. And we saw that. All right, so you could put script up here. Our business was acquired, and it'll then have links. All right, and you can inject functionality into a vulnerable application. You can add a fake login form and things like that. So here's one. This URL, see all this code up in the URL, all this URL encoded stuff, that is the code that does this, and it prints this whole fake page. So you see a whole login form claiming Google is now going to subscription service. You have to send a credit card number to keep seeing Google. And so you're going to google.com, but they had a cross-site scripting here where they could inject stuff. So you can inject a whole fake page on top of it. And this, by the way, I think counts as document object model based cross-site scripting. You took something from here and put it there. So you see something that's terrible. All right. All right, now if you do steal cookies, then of course, this usually is a manual process where you have to manually monitor the cookie and then carry on actions on behalf of users. So it's not generally easy to perform a mass attack with this, although I suppose you could script it. But all right. So inducing user actions is much easier though, where instead of stealing your session cookie and then having to log in as you and do something, it would be a lot better to just get you to do the action in the first place, like Sammy Kamkar did. He didn't steal people's cookies. He made the action perform on their behalf. So he didn't have to do anything. All right. So if you're trying to perform an administrative action, then you just have to put it somewhere where eventually the administrator will see it and other people will see it and it will fail. But it's easiest to just put your payload in an automated action. So browsers trust JavaScript with cookies from the same website. And so autocomplete might fill it in, and some sites, if your sites are in trusted sites, then you can run arbitrary code with ActiveX and other things, although I think ActiveX is pretty much dead these days. I see a question saying what kind of engineering is that, but I don't know what the question was about. Anyway, all right, and so you can also log keystrokes in the browser, of course, capture browsing history. You can even send requests to local URLs to do a sort of port scan of local networks, in principle from JavaScript. So let's try 12b. Well, guy offering $10K for breaking his 2FA email. Well, that's right. Yeah, well, I don't know if it's engineering. I think it's public relations or something.
Social.
What's that?
Social.
Social engineering. That's right. That's right. The attack. You could call that social engineering. It had a technical component, but it was also social engineering. It tricked them into clicking on it. Almost every attack involves some social engineering. Attacks that can compromise the system with no user action are highly prized. Those are the most dangerous ones. Most of them involve tricking the user into making a mistake. ghosts, I guess. All right. All right, so which one got the $10,000 prize? That was the webmail, the two-factor email. All right, and which one did Chemi Kamkar do? All right, that was MySpace, very famous attack. All right, which one got administrative access? That was Apache, all right. And, okay, which one is labor intensive? Session hijacking is the one that's labor intensive. You have to handle them one by one. Anyway, let's see who the winners are. Austin again, good. All right, I know who that is. And tap, all right. Now I see a message in the chat from Sasha saying I forgot to put my name, perhaps meaning you didn't join the Kahoot, I guess. It let you in, but late. Yeah, they will let you in, but if you don't get in from the start, you're at a disadvantage. All right, anyway. All right. So anyway, let's talk about how you deliver this. You have to clearly have to deliver a malicious URL to the user, so you often just send them an email with the URL or an instant message. Another thing you could do is post it on a website and wait for them to visit the website. And the most common of these is a watering hole attack. These became well known after China did this. The government of China wanted to attack Tibetan nationalists, so they poisoned websites about Tibetan culture, knowing that Tibetan nationalists would go there and get infected, and that way you don't have to trick them into like clicking on a link or anything. So that's all right. And then you can deliver these various kinds of attacks. Another thing you can do is buy an ad and put malicious content in the ad. Even if the company that sold you the ad tests their code, you could put up a harmless ad for a day and then change it to a malicious one. And it will take time for them to notice. So that was a pretty common one for a while. All right, and often there are ways to send data from, tell a friend, recommend this site or something, and sometimes you can use that to send a malicious URL to someone that actually appears to come from a legitimate company. So then you can, so most commonly you deliver these in-band, you store it in your name of documents, your name, email address, messages, something in logs, uploaded files. You know, you really send the data up to the server, and the other user downloads that data from the server and gets the script to run. You can also deliver it out of band, like the one you had before, where you get the server to send email to person, including script. And then you can typically chain it, which you may remember this is what happened with that Apache attack. They used cross-site scripting to steal a cookie, then they came in with a cookie, then they put in more attacks. Typically, cross-site scripting all by itself doesn't do a whole lot of harm, but it's part of a chain of attacks to get you in. So for example, you can inscript script into a username, your display name, then here they find another flaw that lets you change other users' names. You can now add token stealing cross-site scripting to many names and get their credentials. So it's the kind of thing. You find a second flaw that goes with it, typically. This is why a lot of people I've heard for the last several years have said it really is no point rating vulnerabilities by CVSS score. You really should just say vulnerable or not vulnerable, and you should really patch them all. I don't know very many people that are motivated to do that, although one of my clients that I'm a consultant for does want to patch all vulnerabilities. We'll see how that works. But certainly that would be a good practice if you can do it. But you might regard it as too time-consuming and expensive. Anyway, so you want to find these things, just insert this script tag everywhere and see if it runs. That's the fastest way to find it, but it won't find them all. Sometimes you need different punctuation marks in the front here, as we've seen with SQL injection. Another issue is there might be a defense. The defense might be blocking script tags or some of these characters, and then you'll have to sneak it in. With something like this, you can use URL encoding to, let me just zoom in on that. Better use URL encoding. You can put in double script tags. You can put a null byte in front of it to hopefully terminate the web application firewall. There are ways to maybe sneak past. So if you have an attack that doesn't simply return the attack string, but it has sanitized it or decoded it or something, then you might have a problem. But in DOM-based cross-site scripting, it's coming right from the URL, so it might not pass through a sanitization feature. Anyway, so you submit an alphabetical string at each entry point and watch to see anywhere that comes back, where the server repeats the data you sent, and then you can try to find out if you can inject script there. So you make a string like this, my XSS test, and then a few random letters, send it everywhere, name, cookie, everything, and see if it comes back. And then you'll submit it as every parameter one at a time and see if you get that string coming back. Any place you get it back, that means the server repeated something you sent up there, and you might be able to inject script there. All right, test each one to see if it's exploitable, and so it goes. So here's a demo of one that's a little hard to exploit. Let me get to this one. This is demo 5. I think I go here. All right, so this one here, we got an image resizer, 50% and 50%. So when you go there, this image appears, and it's at half size. Now, if you view the source, so here we are. It's a source evilcat.jpg, height equals 50%, width equals 50%, which is fine. The problem is this came from the user. So I control a number that's inside there. So that means if I try to do a normal script injection, like just this, it's not going to run. Now, the reason it didn't run is, even though it injected it, see, it was inside a string. So it was not interpreted as script to run by the browser. So what you have to do is get out of this string. So you're going to have to add an apostrophe and a greater than sign to close it. And so the injection that works is this one here. You give it the percentage and the apostrophe and the closing bracket, and now you can inject stuff. So now the script runs, and if you look at the source, you see it completed this height equals 50%, then it ran the script, and then I had some extra junk left over. I had some collateral damage. That's why you see some extra code on the page. So if I wanted to be cool, I'd add another opening greater than sign here to get rid of that. That should work. Let's try that. If I want to avoid leaving that clue, I would go to the end of this and put in an opening one. And now that should eat it up. Oh, didn't. How rude. Well, thought that would work, but I don't know why it failed. Maybe the apostrophe fouled it up. Let's see. View page source. I should be able to figure out how to eat it up. Script alert / script. Then why isn't that just hidden? Well, what if I make a complete, I'm just going to try one more before I go on. What if I put in a complete tag there? There, see what that does. Yeah, that did it. Now it turned into valid but invisible HTML. Now, I turned that into something here, which doesn't do anything, but now it doesn't show up on the page. So my script, my attack was actually all of that. All right, anyway. All right, so that's an example of it where you control something that is a little bit harder to exploit. And by the way, the other way you can do it, you can have an on-click method handler. That's worth demonstrating. This one here ran the script right away. You could also put in a handler. This is another way to insert JavaScript in a page, which is kind of bizarre. That's why HTML is really weird. So now you have onClick, which is an event handler inside an HTML tag. So it doesn't run, but when you click this, then it runs. And so anyway, there's many, many ways to hide JavaScript in a page. And so very hard to track them all down and stop them. So that's the thing. So if you control something inside a parameter, then you're going to have to add some punctuation marks to break out of that container to run your script. All right. And so here I've got a variable, script variable a equals. I'm controlling something that's already in a script. So I just need to put in the right punctuation marks and then an alert. And the right punctuation marks at the end to get rid of it. The same kind of thing. If you're inside script tags already, you don't want to put in more script tags. That's why you have to play with these punctuation marks. The same thing's true of SQL injection. You have to play with the punctuation marks until you find the right combination that will break out of the container. All right, here's another one. If you have an attribute containing URL, ahref equals something I control, then you can use JavaScript alert one. Since I have a URL here, I can make a URL that will run JavaScript. JavaScript : will run JavaScript. Like HTTP : will load over HTTP. Let's see. Simple encoding of less than, greater than, and maybe semicolon fixes all of this. No, Sasha, it's a very good question. Encoding those special characters will not block all this. What it will do is it'll block simple attacks, but you can still sneak them in with these tricks. You can URL encode those characters so they might not get caught. You can put a null byte before them so that the scanner might not find them. If you could really be sure that you got rid of all less than and greater than signs, that would stop it. Although it wouldn't stop the event handlers that do onClick equals that don't use less than and greater than. That's why this deny listing thing, where you try to identify the bad stuff and remove it, is a very weak defense. It is very hard to block all possible bad attacks, as we're going to see. It's much better to do allow listing, where you only let through things you know are good. It's very hard to think of all the ways a bad guy can sneak a bad character in there. All right. And so we talked about this. So we have defensive filters, like what you were just saying, where they're trying to do something, they blocked your input, or accepted your input and did some kind of sanitization or truncated your attack to a fixed length. These are three common types, and there are ways to sneak through each of them, as we talked about. You may see an error message like this. That server error in application, a potentially dangerous request was restricted. I've seen this quite a bit. When you tried to sneak code in, like a less than sign in, it'll give you the error. So you can just try removing parts of the string until the error goes away, find the substring, and then you know what bypass methods to top, like insert a null, URL encode things, and all that jazz. All right, let's try another Kahoot, which is number 3, which is here. All right. Yeah, that's a very good question, Sasha. That's what people think. They think that deny listing will save them. But deny listing is usually not enough. It's better than nothing, but it's not a very strong defense. Mushrooms. I'll wait a few more seconds. See if anybody's still coming. All right. So what attack posts a malicious page and waits for targets to naturally go there? That's a watering hole attack. All right. All right. What cross-site scripting displays scripts that did not come from the server? That should be a D, DOM-based. Document Object Model-based has script that is taken from, say, the URL, some other source, so it did not come from the server. But it appears on the page. Your browser puts it on the page as if it came from the server. And if you control the value parameter, what injection will work on this code? There should be an image. There's an image. So you control this thing, foo. This one will work. And by the way, here's another thing about deny listing. Remember, as a student pointed out, if you block less than and greater than, that's fine, but it wouldn't stop this attack. This attack does not use less than or greater than. So it's that's the thing about these deny listing. Deny listing is a weak defense. Jose. And Josie. All right. And faces again. Good. All right. Good. Just add a double quote to the list. That's right. Exactly. Sasha's got it. That's where you enter the world of badness, where you try to have more and more deny listing. And that's one way you can go. But, you know, it's always going to be weak defense because the bad guys are endlessly inventive at finding more ways to sneak by. Anyway, it's 6:55. Let's take a 10-minute break and pick up at 7:05. So we got another section to go through.